Good morning. I just got up and had breakfast. How are you? Hell yeah. Very good. So, my name is Jenny. I'm going to talk about NASA Astronaut Training and what it has to do with game design. So, this is a story of a small indie studio in Melbourne that ended up working with NASA randomly through a weird accident that happened on Reddit. And I'm going to tell you the story today. And I'm going to tell you a little bit about myself and a little bit about game developers and why you should work with us. So, again, my name is Jennifer Scheurle. If you are interested in talking to me after this and you didn't catch me after the talk, if you have questions that you can't think of right now, anything they like, this is my Twitter handle. Feel free to tweet at me. Feel free to connect with me afterwards. I also have a slide in the end where my email address is on, if that's more comfortable for you. But yeah, feel free to tweet at me and ask me questions. Currently, I'm a lead game designer at ArenaNet in Seattle. I moved there in January, but before that, I was here. I lived in Melbourne for 2 years and worked at a company called Opaque Space. And everything started with this picture. So I'm a bit of a storyteller. It's kind of what all game developers have in common to a degree. So I'm going to kind of tell you the story of how this entire thing came to be. So a few years ago, I found myself in a position as a game design lead at the Australian company called Opaque Space. The company developed games, but we had a focus on virtual reality. It was pretty new and pretty cool at the time. We were at the cutting edge of everything. And the image you see on screen was part of one of our tech demos that we built at the time. You see that we have this beautiful image of Earth. It was cutting edge because at the time we made a scrolling Earth texture based on satellite data, and it had like live weather patterns, like tornadoes and anything cool. It was live streaming, and it was in Unreal Engine. And the story starts with this picture because this image and some others made it to Reddit. And it turns out that NASA engineers are on Reddit quite a lot. So before I go exactly into how that worked, I need to give NASA a little bit of credit. This image is pretty cool and pretty dear to me because if you know anything about NASA and how they train astronauts, you may have heard that NASA has been working with VR for a very long time already, actually over 20 years. NASA VR looks really strange and different compared to what you know nowadays. A lot of the headsets are really big and bulky and have like gigantic backpacks in the front and in the back and whatever. It's a system called DUG. They have been developing with that engine and that technology for, again, over 20 years. So all the virtual reality that we know as a cool new technology has been old to them. However, when VR headsets came out for the general public, for only a couple $100, it changed the game for them, obviously, because now they could develop on this new technology for much less money, but also in a new engine, so they were unexperienced in working in Unreal or in Unity, which is what game developers use to usually develop on these platforms. So essentially, they were looking for people who could help them make things for those new platforms. And they went to Reddit, and they saw all our footage, and they wrote us an email. And that's how it happened. What was born out of that was a franchise called Earthlight. Earthlight is it's a weird thing nowadays because it has multiple installations in the weirdest ways possible. It became more of a platform rather than just one game. But you can actually download a version of Earthlight, a public version of it from the Vive store if you want to play it. It's a very short game, 15 minutes. But essentially, you go on a spacewalk in a proper NASA astronaut suit, and you try to complete some tasks there. So yeah, Earthlight became kind of a platform. We have made multiple games for Earthlight. Earthlight Spacewalk is the first one that we made that has a public version of it, but a version that is used at NASA for astronaut training. We made Earthlight Lunar, which was shown at your local science works for a while. I don't know if it's still on. I don't think so, but if it's ever still on, if you look for Earthlight, it's pretty cool. I'll talk about it a little bit later. So for everyone who hasn't seen this before, I kind of want to show you the trailer so you get a little bit of an idea of what it is. Let's see if this works.
Transmission for the airlock, from our indications down here, you have a GOTO.
I always get a little bit emotional seeing it because I really, really loved working on it. It's been a while now. Yeah, that was all footage in-game from our Unreal Engine demo. This game actually won Game of the Year at the Australian Game Dev Awards in 2017. I hope I'm saying this right. But yeah, we didn't expect it to be so big, and people really loved it. It's very short again, but you can play it if you download it from the Vive Store. A very early version of Earthlight, you can see here. I hope this plays. Play. I don't know if you can see this later in this video, but we had this issue where essentially what we're doing with this game was we had to teach people something in 5 minutes that astronauts train years for, which is moving in zero gravity. That is what games are amazing at. Games can teach you really complex systems, really complex things in a very short amount of time. That's what game designers and game developers are fantastic at. We are teachers, essentially. So this particular first demo has like an auto rotation on. I hope you can see this. So we're kind of auto-rotating the body for you, so you don't have to deal with the 6 degrees of freedom right away. The final game that we released has 6 degrees of freedom, and you can actually move around completely freely. But it's very unusual for people to learn how to do this, because it's completely well outside of your everyday experience. You're basically moving around in a very planar environment. Unless you're a diver, this is not something you're used to. But the game teaches this to you in 5 minutes only, and you have to traverse with your hands using handlebars. Yeah, the later version had 6 degrees of freedom. It was extremely difficult to teach. If you're downloading my slides after YOW is over, after the last slide, I have actually an additional couple of slides that explain how we solved that problem in particular and in detail, if you're interested. But yeah, for now, we're going to move on from that. Oops. Next slide, please. So this is really cool. I wanted to show this to you because I'm pretty proud of what happened in this image. What you can see above is our company founder, who was at the NASA Johnson Space Center and the Argos. Who knows what the Argos is? Has anyone ever heard of that? Argos? No? No one? OK. The Argos is NASA's gravity offload system, essentially. So imagine a gigantic warehouse with a whole bunch of pulleys and like trapeze, basically, that straps you in, and it simulates all kinds of different gravity settings. It could be a zero gravity, or a moon, or Mars, or whatever you want. And it basically measures like your body weight, and it simulates zero gravity. So we got to play this game in VR. You can see the headset on his face. In this offload system, using actual handlebars on the floor. So what you saw in the video, we got to play at NASA with this. And it was really fascinating and fun. We learned a lot working with them, and I'm going to talk a little bit about that in a second, because working with NASA is pretty unique and probably nothing short of life-saving. So working with NASA is a really strange thing, because you feel like you know so much about this institution. It's almost like mythical at this point. People only working on the future of this entire species. No big deal. So you have to kind of consider special parameters that are social and educational. It includes honoring their long-standing work and history for the future of all of humanity, ensuring that our material promotes their work and does not misrepresent it. Given that they are a government institution, they run on taxpayer money, so it's very delicate to make sure they are represented in a proper way. And all of a sudden, you work with people who are fundamentally smarter than you. Honestly, I felt pretty outgunned most of the time. Given that their problem-solving techniques are global and they reach many, many people, whenever they throw a new problem at you, you can probably be quite sure that a lot of other people have thought of solutions already that you are thinking of. So you're basically constantly challenged to be better and be, well, world stage best at problem-solving. We had to learn to teach inherently unique and alien skills, such as moving around in zero gravity, as one example. We were all of a sudden in this position where we didn't only have to teach game systems, but things that we didn't even know existed in the first place. So you learn to do problem solving and teaching on a whole new level. Well, and in our case, since we were one of the first people in our industry, game to games industry, to work with NASA, we found it to be very important to us to represent our industry and what we do towards NASA in a positive light, so that maybe in the future other people can work with them in other capacities. However, I feel like there were so many overlaps too with our work and how NASA actually works, and that's why I thought it was such an interesting fit. So the way NASA defines problem spaces is very similar to the way game developers work. It's a fundamentally iterative process due to many unknowns during the development. So if you think about a game, given that it's a virtual world, then everything has to be a decision. Every single door, every single plant, the way everything looks is a decision. So you make millions and millions of small creative decisions along the way of years and years of development. So it has to be an iterative process by default. There's no other way of making games but to iterate on what you got. And NASA works the same way, because they don't even know what kind of problems they have to solve tomorrow. It also requires the collaboration of many, many different departments. Games usually have 3 core departments, which is engineering, design, and art. But there are many, many other departments that come together too: sound design, QA, and so on. So in the end, we have to somehow bundle this enormous amount of creative energy into one product and make everyone be on the same page. Obviously, it works best when the goals are clear and focused, which is one of the main issues whenever we define problems in the games industry. And ideally, it's a problem space without individual egos. That's probably the one thing that I learned most when I worked with NASA, because you can't really afford having egos when you're working on the future of humanity. It's kind of too important to get egos be in the way of that. So who here in their company or in their work works with problem briefs? Like when you have a problem to solve or a new feature to develop, do you do problem briefs? Has anyone done problem briefs? Hands up. Oh, 1, 2, 3, maybe? Okay. Problem briefs is probably the one thing that I took away from working, collaborating with NASA that I still use in my everyday work now. I'm going to try to make this a little bit simple so it fits your work potentially as well. But yeah, the way problem briefs work at NASA is the following. Essentially, it includes a factual explanation of the problem. That's a really important part. It means that you have no gatekeeping language as much as you can. Obviously, a lot of that is scientific, but yeah, you try to have no gatekeeping language. You make sure that everyone who reads the problem brief has at least a basic understanding of what you're trying to solve. If it includes any specific words or scientific data that you need to understand, you give resources so people can understand what the problem actually is. And it is inclusive language, because problem briefs are sent out to many, many people, sometimes across countries. It tries to keep the content to goals and does not suggest solutions preemptively. This is super important. I use this every day with my teams nowadays, and I think it has made my work so much better. It means that if you don't suggest solutions preemptively, then people can be more creative in how they help you problem solve and reach the goals that you're trying to achieve with a feature or with whatever you're trying to do. It also helps people challenge your solution later down the track, which makes your solution better. Your solution is likely not the best one. More brains and more people working on one solution is usually the better approach. It also includes psychological drivers behind the problem. I'm going to talk about this in a second to understand what that means. And yeah, keep it simple. Usually, NASA problem briefs are not a million pages of things. It's like 3 or 4. And you try to keep it simple so people can understand what you're trying to solve. So this is, I'm going to give you a better slide. I know it's hard to read right now. It's a lot of text. I just wanted for you to see the whole picture first before I go into the details. This is what we call a design matrix. We use this opaque space to kind of get everyone on board with the same design direction. Usually it's a method where you come up with 3 to 5 questions that you can filter ideas or solutions through before you implement them. So let me just get into the details of this. For Earthlight, we had these 3 questions. Is this feature meaningful? Is this feature authentic? And does this work in virtual reality? So let me just get into the details of it. Is this feature meaningful? Essentially, we wanted to make sure that everything we implement has educational value or skill value or emotional value, is somewhat empowering, or sets the story or the drama of the game somehow. The drivers behind that are meaningful basically means the human experience comes first. We agree to stray from authenticity if the feature is meaningful enough. So to give you an example, we made a 6-player moon Earthlight version, basically, that you strap yourself into a headset and a backpack and you go on the moon. And when we had our first tests for that one, people just wanted to be on the moon and look up and see Earth from moon, because obviously that's beautiful. However, astronaut suits kind of suck, so you can't really do that. Astronaut suits are really restrictive, and you have a helmet on. If you look up, you just see the inside of the helmet. It's not connected to your neck, so you can't really do that. So we had to somehow find a solution for this, because every single person really wanted to see Earth from moon. And technically, you would have to lie down, and it doesn't work in VR, and it's awkward. So what we did was, for the player themselves, we just cut off the helmet bit of the full body model we did, and we removed it for the player. But for everyone else around them, they still had the helmet on. So everyone believed that they were wearing a helmet, but they didn't. So you could just look around everywhere and see Earth from the moon surface. It was meaningful enough for us to implement that and not be as authentic as we should have been, because it was more important to us that people have this beautiful moment that they will never have in their real lives. Is this feature authentic? Obviously, we value the collaboration with NASA, and we wanted to pave the way for others working with them, so we wanted to make sure they have a good experience working with us. NASA couldn't be ridiculed, have its culture misrepresented, or be misrepresented for sensationalism. We wanted to make sure we don't go the Hollywood route while we were working with them. And then, last but not least, does this feature work in VR? We wanted to, as one of the first people bringing VR to the masses, if you want, wanted to make sure that new technology is introduced in an appropriate manner. So if I strap a headset on you for the first time in your life, and you get sick and you have a terrible experience, we have failed you as the people who bring new technology to you. I think there's a responsibility in making sure people who are starting out with a new technology have a good experience with that. So it was part of our mission statements, if you want, that our features work in virtual reality in an appropriate manner. Okay, now let's get to my favorite part. What is it like to work with game developers, like me? I like to say to technology folks that we are basically user experience experts in ways that other industries are really not. Our work is against common belief, based on deep compassion and love for our players. I use this word very deliberately, because I think that is really what it is. There's no way you can work 8 to 10 hours a day and kind of break your back over this if you don't love your player. And it's very hypothetical, obviously, and it's not a real person, but games take sometimes 3 to 7 years to make. It's an expression of love if you try to make something for the enjoyment of others, and there's no other way of expressing it. We love our players. We are also natural teachers, and we know what makes humans tick. So a lot of us have some background or some knowledge in behavioral psychology, and as part of the game designer's skill set, it's kind of how we function. I'll have a whole lot of examples for you later of how we use that, and you'll find that probably very funny. But yeah, I'll talk a little bit about that a little bit later. For now, as I promised, I wanted to talk a little bit about psychological drivers. So whenever I develop a new feature for a game, I include a section on psychological drivers in it. What that means is I basically talk about why do your players care about the system, what drives and motivates them to engage with it, and psychological drivers basically help explain your solution to your team. I'll give you an example in a second, but if my team knows what I'm trying to achieve within my player, then they can come up with better solution to implement whatever we're trying to implement, or they have better ideas for how to extract that from a system, or how to even set it up for scaling. So it allows my team to basically be smarter when implementing it and be more interesting when coming up with solutions. All right, example. In Earthlight, there is a feature that is basically the GoPro camera feature. I don't know if you've ever seen this picture. That's a real astronaut taking a selfie, because why the hell not? We wanted to introduce that feature in Earthside because of multiple psychological drivers. In this case, familiar tasks. VR can be very overwhelming. You have this gigantic headset on your face, and you don't know what's going on. But if you have one familiar task, like taking a picture is something everyone knows. It kind of eases people into the experience. Personalization, taking photos of the environment allows for the player to kind of enjoy the environment in a very personal way, through their lens if you want. There's exploration. Taking photos specifically allows for explicit exploration of the visual environment, maybe change perspective if you're looking for this really cool shot. And finally, souvenirs. Taking souvenirs away from things makes the experience yours, and you have a memory forever, potentially. So that would be an example of how to introduce psychological drivers if you make a new feature for something. Okay, so now we're getting to my favorite part. We're calling it hidden game design. It's a little funny name. It's kind of the big part of my work and what people know me for. Hidden game design is really just design. But we call it that because it's deliberately hidden features or systems under the hood of a game that are not seen by players, that help people have a certain experience, feel joy or sadness or engagement or whatever a game is trying to do. And I'm going to walk you through a couple of examples, probably from games that you have seen before. I'm writing a book about this, so it will come out at some point next year. I can't give you examples exactly when. I'm still writing it. It's hard to write a book, as it turns out. But yeah, next year, let's talk a little bit about examples. Rubber banding. Who has played Mario Kart? Yes, hands up. Good audience. Excellent. So rubber banding is probably one of the most well-known hidden game mechanics out there and largely implemented in racing games. Essentially, what it is it allows the AI for players in games to catch up to you, no matter how far ahead or behind you are. The reason why we put this in the game is to create conflict and tension between players. So what it means is, in Mario Kart, you use items to fight one another instead of just racing. Like the blue shell or other shells, you can basically wreak havoc among your fellow players. And the game would be boring if you couldn't use those items. So the game tries to rubber band everyone together so you have opportunities to use these items and create conflict between players. People hate this mechanic, because whoever has ever played Mario Kart and you were in first place for the entire time, and 2 meters before the finish line, a blue shell hits you and you're all of a sudden on 6th place and you lost. That is what rubber banding is, and that's why people don't like it very much. Next one. This is called Coyote time. I've heard other words used for it, but you can be pretty sure that every platformer you've ever played implements this mechanic in some shape or form. As soon as I point it out, you will see it in the video what exactly I mean. Coyote time basically refers to a small window after the player character has already fallen off the ledge where a jump is still valid. You can see it in the Rayman franchise here that you basically already fall off the ledge a little bit and you can still jump to basically accommodate for human error. Humans are pretty bad at judging distance or in fact, speed, especially when both of these things come together. You're pretty bad at this. So the game has to somehow accommodate for human perception errors. That's why we implement Coyote time. All right. Now let's get into more meat of this and less well-known mechanics. Who's played BioShock? Ooh, good audience. Very good. BioShock is, despite having many combat elements, basically a game about telling a complex and rich narrative. That was one of the overarching goals when the developers made this game. So the focus for the designers was to favor that over combat difficulties, which is why they implemented a hidden game mechanic that has been implemented in other games in similar forms ever since. The first shot from every enemy attackers always misses you. You'll see it in a second. So essentially, the thinking behind this mechanic was to build challenge in combat situations that doesn't feel unfair and gives players a chance to overcome the challenge. Getting hit by an enemy from off-screen or where you don't know where they're from is pretty boring, so essentially the first shot always acts as a warning shot. You can see it in every single scenario you see on screen. First shot always misses you. It's pretty easy to make AI in games that are really boring and they will shoot you from the other side of the map with 100% accuracy, so, you know, essentially making AI that is interesting to overcome and that you can react to is what our task is. That's why we implement small hidden little things like this one that help you out in the situation. Assassin's Creed players, hands up. Good, I'm so proud of all of you. Okay, so Assassin's Creed, obviously many, many iterations of this game by now. The mechanic I'm going to talk about has also gone through multiple iterations. So depending on which one you've played, you may have seen it in a different version. But the way it actually works is, instead of a one-hit killing blow, the game does this weird animus glitching that you see on screen. And instead of actually killing you with that killing blow, it gives you a couple of seconds to recover from it instead of killing you off instantly. We call these like safety belt mechanics. We give you just a little bit of time to recover from a potentially, killing blow, essentially. So when I spoke to the folks working on Assassin's Creed Origins, they explained to me the way this particular mechanic works. So in AC, the health bar is broken up in several chunks of health portions. In Origins, that's 3 sections. On the top left, you can see that. When players receive damage in combat and are on less than 100% health and have not taken more damage for a couple of seconds, the current health section they are in can regenerate. Players can't really regenerate beyond the block they are currently in. But if players are above 66% health, which means 2 full blocks, and still in the third, taking a big blow still always leaves them at least on 7% health, basically giving you a chance to recover. Once you are below that 66% threshold, however, you can be one-shotted. To help players out in that situation, though, in those 2 lower health sections, you recover faster. So you can recover faster health, essentially, while you're in those 2 sections. So the reason why we do this is we want combat encounters to feel interesting. We want you to basically lose health faster at the beginning of it, and then just feel like you overcame overwhelming threats. We want you to feel like you just got away by the skin of your teeth, and you had a really interesting combat encounter where you struggled, essentially, with the enemies, and you just outsmarted them in the end. Okay, Uncharted. This is a little bit more esoteric and strange, and a little bit more technical, but I hope you get it. Uncharted, who has played Uncharted? Sweet, a little bit fewer people, that's fine, it's a different game. So Uncharted is an extremely cinematic game, basically. We wanted to make sure that people have the perfect cutscenes. They have the perfect experience no matter the skill level. The Uncharted series pretty much lives on climbing sections. It lives on you basically going straight into beautiful cutscenes and tense moments. And we want to be sure that every single player, no matter how bad they are at the potential actual gameplay, have the same experience. So I'm going to show you 2 videos. The first one is one where the player is not very good at traversing the falling segment that we're going to see. And the second one is where the player is very good at that. You'll see it in a second. All right, let's go. So this is debug footage, in-engine footage. You can see in the free-floating camera the green spline. This is the falling surface, essentially. So this is what you're going to climb up on, and it's going to fall as you traverse it. When this player is playing, on the left-hand side of the screen, you will see a graph that indicates the speed of this player. So pay attention to that on the left side of the screen.
You gotta be kidding me.
Here we go. Okay, you can see the speed kind of dropping and going up and down. So this player is not particularly good at traversing this particular part of the map. So the game does some interesting stuff to make sure you still have that perfect, traversal and transition into the cutscene. This video shows the same sequence, but with someone who's perfect at this run. You will see, again, on the speed meter, that this person is doing much better than the other one. Pay attention to the graph on the left. Speed is up the entire way. Perfect run. Now, how does the game figure out to give you the exact same experience even though the first player was way worse at this than the second? I'm going to show these side by side now. And the way it actually works is the system measures your position and your speed along the green spline that you saw, and it adjusts the speed of the falling surface according to how well it predicts where you will be on the spine. So if you see this together, you will figure out that both of these have the same cinematic experience, even though one player is much worse than the other. Perfect. You can't really see the numbers, but essentially the way it shows it on screen is that the right surface is faster than the other one because it adjusts depending on the player speed of the falling surface. Now, my favorite example, because it's absolutely outrageous. This is a very old game. Has anyone in here played High Octane? Ooh, I'm gonna ruin your life. High Octane, a game, very old game, 24 years old, by Bullfrog, I think. It's a racing game, essentially. You can see all the vehicles that you could race in this game on screen. Before racing, you could basically pick one, and it would show you all the stats on top. So velocity and speed and handling and all the things that you usually see when you pick vehicles. However, under the hood, all of these are the same. Turns out, for 24 years, no one has ever figured it out. For 24 years, people have been arguing in their friends' groups and in school grounds and whatever, which vehicle is the best. And it didn't matter, because under the hood, they are literally all the same. It was awkward because it was implemented this way because they ran out of time. Oops. But again, for 24 years, it did not matter. For 24 years, no one has ever come across that all of them handle the same way. And I thought it was so fascinating when Alex Trowers, the game designer on this game, actually told me, because it is evidence for the human perception being completely flawed, and that you can basically fool everyone into believing something for this long, and no one ever catching up on the lie, if you want. That leads me into the next slide. So, game designers work for the human perception. Humans are pretty imperfect. We are flawed. We are strange. We have perception errors. We're very bad with things like chance or math. You basically can guarantee that every game that has some sort of 50% roll doesn't actually give you a 50% roll. If I give you a 50% chance for something, you will expect that every second time you will win. Which, that's not how 50% chance works. That's not really how that works. So games usually taper 50% chances into, turning into 75%, or then giving you a 100% chance if you missed a roll twice. Just to give you the feeling that you have a 50% chance. Feeling is more important than actual systems. So that's what game designers do. We have to make sure that what we implement feels right to you, even though it might not be true. All right, in conclusion, game designers have employed unusual ways to challenge and engage players since the beginning of our craft. This is what we do. We are user experience experts. We are keen to give players the experience that they need. Sometimes we know better what they need than they do. I wish training and simulations could make leaps in the next few years if they employed game design practices in similar ways as we do. I wish we could see and rethink the field of training and simulation more. I wish we could go and imagine if we could use ramping up difficulty curves in simulation. What if I could teach you to fly a rocket not only by putting you in the cockpit and making you fly it in a virtual environment? What if I could give you training wheels for the first couple of times you try it? What if I could show you the vehicle from multiple different angles so you understand and get a mental model of what it actually is? What if I could use storytelling in context to teach you? Humans are so strange and unusual. We don't learn just by having facts in front of us. We learn through stories. We learn through people and things that we can relate to. I want this to be implemented in training. I want us to not be afraid of making things fun and interesting and engaging, because that's how humans have been learning for forever. And of course, technology is best when it's user-focused, diverse, accessible, and approachable. And all fields that I just mentioned are things that game developers and game designers have pioneered in for many, many years. I really want to have some time for questions, so I'm going to leave you with this funny GIF of me dancing as an astronaut in VR, because I can. I hope that we can talk a little bit about this one a little bit more in the questions, because I really love working on it. It's a 6-player, well, multiplayer VR game that you go in and you see the moon surface, and there's so many interesting things that happen in this one. People know that they enter the game in an empty room and nothing is there, but they will still step over every ledge and duck onto everything, even though they know they're in an empty room. But perception is more important than reality when it comes to humans. Thank you.